Okay, let's unpack this. Imagine you've just installed a shiny brand new NVMe drive into your home lab server. You're feeling good, right?
Yeah.
Getting everything set up. And then, maybe out of curiosity, you check its health stats, and bam! That percentage used field stares back at you with a number that feels, well, wildly disturbingly high. You just installed it. This is supposed to be fresh out of the box, that sinking feeling. It's surprisingly common for home lab enthusiasts or really anyone setting up new storage. Today, we're cutting through the noise to reveal a surprising truth, why your brand new NVMe might be screaming, "I'm dying," when it's perfectly healthy, and what truly matters when assessing drive longevity. It all comes down to a number that's often misunderstood, and we're going to demystify it for you. Our specific case today involves a Kingston NV3 1TB NVE drive installed in a Proxmox node for VM storage. After just a month, okay, and less than 1 terabyte of data actually written, this drive reported a whopping 16% wear. Now, this is on a drive rated for 320 terabytes written, or TBW. So, the initial panic, the forum searches, the suspicions of firmware bugs, or even fake drive, it was all there.
Exactly. It's a classic mystery, isn't it? Is the drive truly on its last legs, or is the drive's self-monitoring analysis and reporting technology, what we commonly call smart data, simply misleading us? That's the central question we're going to unravel today. We'll break down the underlying mechanisms and common theories to help you understand what's really going on when these numbers don't seem to add up, and ultimately give you the clarity to know when to panic and maybe when to just keep calm and compute.
Right, so let's dive into this alarming anomaly. The owner was running Proxmox 8.4.6, and this NVMe was set up about a month ago, primarily hosting a few VMs. We're talking basic Debian defaults, weekly trim, which is essentially the OS telling the drive which blocks aren't needed anymore, helps efficiency. Nothing extreme. And according to Smart, the total data written was just 922 gigabytes. That's it. Contrast that with the drive's endurance rating, a robust 320 TBW before it's supposed to hit its rated lifespan.
Yeah, and what's striking here is the sheer mathematical discrepancy. It's huge. If Smart's percentage used was accurate, 16% of that 320 TBW endurance means the drive has effectively burned through the equivalent of about 51 TBW already. Think about that. 51 terabytes of theoretical writes for just 922 gigabytes of actual data written. That's not just off, it's wildly disproportionate. And to make it even more confusing, that wear percentage even continued to creep up. Another 1% in just 2 days, despite very light activity. Now, even if we consider the drive uses 4 bits per cell NAND, QLC, right, which means each cell might be written to more often, we'd still only expect maybe 4 writes per cell max at this point. 16% wear is, well, it's simply inexplicable based on the reported data written.
That mathematical discrepancy is truly mind-boggling. Really makes you scratch your head, doesn't it? So if the numbers are this wildly disproportionate, what was the very first step the owner took to investigate? Well, naturally, the owner's first thought was firmware bug. Makes sense. They took the drive out, moved it to a Windows system, and used Kingston's own utility to check. No updates available. The firmware, P3BR0823, was supposedly current. So it seems like the obvious solution wasn't so obvious this time. This perplexing situation led to a lot of discussion in home lab forums and among storage veterans, and from those conversations, various theories emerged trying to explain this huge discrepancy.
Okay, digging into the theories, the first common one that surfaces often revolves around the drive's internal workings, a firmware glitch and wear calculation. This suggests it's basically a math error within the controller itself. The drive might be pulling the wrong raw value or perhaps misreading its own internal counters, which then makes that percentage used metric a complete liar. And there's even concrete evidence of this happening, like a Proxmox thread documenting a case where a drive reported 99% wear after just a few terabytes written. Clearly not normal behavior for a healthy drive.
A complete liar is a strong statement. But it begs the question, if it's just a software glitch, why isn't this more widely known or patched? Is it truly just a display error? Or could it hint at underlying issues? And what about background activity? Does that play a role?
Yeah, beyond a pure firmware glitch, another common explanation emerged. The idea of unreported writes, or background wear. This explores the idea that the drive might be moving data around internally, in ways that consume extra write cycles that aren't visible to the user. We know SSD controllers perform wear leveling, constantly shuffling data to distribute writes evenly across NAND cells. But if a drive doesn't get enough downtime, or if there are issues with its cache management, it could perhaps disproportionately hammer certain cells. And while the original owner insisted their workload was light and steady, some theorized that small files and constant rewrites. Even if they're small in total volume, they could significantly amplify write amplification, where the drive writes more internally than you ask it to, leading to unexpected wear.
Right amplification can be a silent killer sometimes. Then there's always the dark horse theory, a fake or refurbished drive. It's an unfortunate reality that this does happen. We see it. One commenter shared their experience with counterfeit NVMe drives bought from Amazon that quickly hit read-only mode after just a handful of erase cycles. Really nasty stuff. However, for our specific case here, the original owner purchased their drive from a reputable local shop. The packaging seemed legitimate, and perhaps most importantly, a second identical drive purchased concurrently was still happily reporting 0% wear. So while it's a valid concern, it seems less likely in this particular scenario.
Okay, that's a relief to hear, though it's always good to be aware that fakes are out there. So, moving beyond outright counterfeits, our investigation into the drive's actual reported data led us to the fourth theory. Could unsafe shutdowns be taking a toll? The smart logs for this drive showed 133 power cycles and a concerning number of unsafe shutdowns. Now, the owner attributed this to early setup chaos. Multiple hardware swaps, forced reboots on an old Optiplex system. Sure, we've all been there, right? Swearing at a new setup and hitting the reset button maybe a few too many times. But it does raise an important question. Could these abrupt power cuts genuinely mess with the drive's internal wear tracking mechanisms? Could that lead to an artificially inflated percentage used metric?
It's a good question, and it brings us to a wider point. Why can Smart's percentage used field be so misleading in the first place? The crucial thing to understand is that its calculation is entirely up to the manufacturer. There's no universal standard here. Some manufacturers base it purely on write cycles. Others tie it to more internal metrics, like how much of their reserved block usage has been consumed. And sometimes, frankly, it might just be a rough guess, not an exact science at all. Kingster's own documentation even states that raw values may not reflect actual NAND writes. And interestingly, that the counter only updates per boot. What this means is that the number you see might lag behind reality, or it could suddenly leap forward if the drive performs recalculation in a peculiar way. It's a black box, really, and the numbers aren't always what they seem.
That's a critical point, because it really means we can't blindly trust these numbers. Wow. But if manufacturers are so varied in how they report this, is there any consistency we can rely on? So with all these possibilities floating around, what should you do if you encounter a similar situation? If your brand new NVMe drive starts screaming, "I'm dying," after barely touching it, here's your sanity checklist.
First, check your firmware. Absolutely essential. Make sure your SSD isn't running buggy microcode. This often means using the manufacturer's specific tool, even if it requires temporarily moving the drive to a Windows system. It's a small hassle, yeah, but it can save you a lot of headache. Second, cross-verify your metrics. As we've discussed, Smart isn't gospel. Not at all. Compare the numbers from multiple tools like NVMe Client, Smart Kucherol, and the vendor's own utility. Get a few different perspectives. If possible, try to check raw NAND writes directly, as that often provides a more accurate picture than a computed percentage.
Okay, good advice. Next, look for red flags that might point to an external issue. Are there high unsafe shutdown counts in your logs? Have you experienced a lot of power loss events? Or did the packaging seem suspicious, potentially indicating a fake drive? Investigate those thoroughly. Also, if you purchase multiple drives, test another drive. Swap in an identical one and observe for similar behavior. If the issue repeats on a second drive, well, it could point to a problem with your platform or your workload rather than just that single drive.
It helps isolate the variable. And finally, and perhaps most importantly, contact support. At the end of the day, only the manufacturer truly knows what their specific counters mean and how they're intended to be interpreted. Reaching out to their support can help confirm if it's a known bug with that particular model or firmware, or if it's a legitimate failure that warrants a warranty claim. They're the final authority.
Yeah, you have to talk to the source eventually. This deep dive really reinforces the core takeaway. NVMe drives are complex black boxes. They really are. We might see a handful of numbers reported externally, but the actual internal state is often hidden behind proprietary firmware logic that doesn't always tell the full story. It's truly a paradox when one drive screams, "I'm half dead" after a month, while its identical twin hums along perfectly at 0%. That's such a profound point, isn't it? We rely so much on these simple metrics, but the reality is far more complex beneath the surface.
It really is. And while a misreported metric is indeed the most likely scenario in cases like this, you simply cannot ignore weird numbers, especially when storage is as critical as it is for a home lab or, even worse, production systems. You just can't afford to ignore it, because sometimes those numbers are indeed the first and only warning you'll get before a drive decides to, well, give up the ghost. So consider percentage used, a rough guide, maybe a hint, but not an absolute truth. It's crucial to critically verify information and perhaps, just perhaps, keep a spare SSD on the shelf, just in case, because nothing ruins your day like a drive that decides it's done long before you are.